The James Webb Space Telescope has captured something truly amazing: lights that seem to emanate from a city shining from a distant point 4 light years away. This finding has rekindled interest in the possibility of extraterrestrial life. The telescope focused its gaze on Proxima Centauri b, the closest exoplanet to our solar system, and detected mysterious bright flashes. Could they be sign of an alien civilization? Stay tuned for more. For a long time, scientists and ordinary people alike have been eager to imagine what life beyond our planet might be like. Any signs suggesting the existence of something beyond has always been greeted with enthusiasm. Then came a turning point when the James Webb Space Telescope delivered clear indications of life somewhere in the cosmos. While scanning the depths of space, this powerful telescope detected something fascinating on Proxima Centauri b, a distant exoplanet. It observed lights similar to those of extraterrestrial cities, raising the possibility that an extraterrestrial city exists on that distant planet. This idea has generated great excitement and curiosity among scientists who are intrigued because the discovery could be one of that they have been waiting for. It suggests that there could be intelligent beings beyond our current understanding, organizing their societies in ways that we're just beginning to discover. Looking at these distant city-like lights located an incredible 4 light years away, NASA engineers are amazed and wonder how long they will have been visible in space, waiting for our technology to evolve enough to detect them. David Kipping, an astronomer at Columbia University, described the planet where these lights were found as particularly complex. This is because, unlike most rocky planets that absorb sunlight and emit energy in the forms of infrared, this exoplanet exhibits a different behavior due to its unique relationship with its parent star, Proxima Centauri. This discovery, made by the James Webb Space Telescope, underscores its importance. The telescope's ability to capture infrared wavelengths was instrumental in detecting the unusual behavior of Proxima b, which is crucial to understanding the atmospheric conditions of this planet. Researchers plan to continue using this telescope to explore the atmosphere of this planet in depth and even investigate whether it might be habitable. The James Webb Telescope is especially sensitive to infrared light, which allows it to observe what's happening on Proxima Centauri b at night. For many telescopes, it is difficult to detect faint light in the vast darkness of space, but the James Webb Space Telescope is able to pick up even the faintest glimmers of light. This makes it an ideal tool for confirming whether the supposed city lights on the dark side of Proxima b are real. The telescope can detect any artificial light in space if it is within a very narrow frequency band, much narrower than the light emitted by normal stars. Proxima Centauri b has a dynamic relationship with the star. One of the planet's stateside, numerous solar planets capture the star's intense energy, and its spectrum also reflects light. As the planet revolves around Proxima Centauri, it goes through day and night cycles similar to those of Earth, with intense heat during the day and cooler temperatures at night. The planet experiences larger temperature variations mainly influenced by its composition. For example, if Proxima b lacks an atmosphere, temperature differences between day and night would be extreme. Without the moderating effect of atmospheric gases or the oceans, the day side would warm significantly, while the night side would cool to sub-zero temperatures. This dramatic thermal variation is an area of great interest to astronomers, as it offers clues to the atmospheric compositions of Proxima b. The James Webb Space Telescope, with its unique ability to image in the infrared spectrum, can effectively analyze the planet's thermal emissions, providing valuable information about its atmospheric properties. Interestingly, the James Webb Telescope's orbit around the Earth coincides with the orbital period of Proxima b, allowing detailed observations of its day-night cycles to be made every 11.2 Earth days. If the planet has an atmosphere, the next step will be to examine its chemical composition to determine its ability to support life. Signs such as the presence of oxygen, water vapor, and methane would be indicative of habitable condition. If these elements are detected on a planet, it would confirm its potential to support life. This would involve analyzing the light passing through the planet's atmosphere, a complex task. Although the James Webb Telescope is excellent for characterizing planetary atmospheres, it is primarily designed for other functions. It specializes in analyzing variations in the concentrations of water vapor, carbon dioxide, and methane. Despite its limitations in detecting free oxygen, a crucial sign of life, the telescope can also search for other important elements, such as ozone, which indicates a healthy atmosphere. As scientists examine the data from the James Webb Telescope, the search for distant worlds continues, bringing us closer and closer to discovering whether we are alone in the universe or not. It is critical to remember that the James Webb Telescope can observe only a limited number of exoplanets closest to Earth. For more detailed atmospheric studies, astronomers will turn to ground-based observatories, such as the Extremely Large Telescope, which will begin operations in 2028. The LLT is designed to offer a deeper look at the atmospheric structures of distant exoplanets, providing clear and detailed data on their potential to harbor life. Scientists look forward to the operation of future space telescopes like the ELT. In the meantime, the James Webb Telescope remains a crucial tool for the exploration of distant exoplanets. Despite its limitations, the Webb Telescope continues to provide valuable information that could transform our understanding of what exists beyond our solar system, both now and in the future. Researchers have big plans for the space telescopes of the future. They want to develop technologies that reduce starlight to better observe the planets around them. It is like using your hand to block out the sun and see better. By dimming starlight, these future telescopes will be able to study the faint light reflected by exoplanets more clearly, helping to analyze their atmospheres and determine whether they may harbor life. However, this task remains a considerable challenge. Blocking starlight to observe exoplanets is easier said than done. Stars are incredibly bright, often outshining their surrounding planets by orders of magnitude. That makes it difficult to detect the faint light that planets reflect, which is essential for studying their characteristics. To tackle this problem, scientists are developing several innovative techniques. One such technique is the use of coronagraphs. These devices are placed inside the telescope and are designed to block out the starlight while allowing the light from the planets to pass through. By carefully shaping the light waves, coronagraphs can significantly reduce the glare from the star, making the dim light from the exoplanets more detectable. Another promising technology is the Star Shade, a giant flower-shaped spacecraft that flies in formation with the telescope. Positioned tens of thousands of kilometers away from the telescope, the Star Shade blocks the starlight before it even enters the telescope, allowing only the light from the exoplanets to reach their instruments. This method could be particularly effective in observing planets in the habitable zone of their stars, where liquid water and potentially life might exist. These technologies, however, require an extraordinary level of precision. The alignment of a star shade, for example, needs to be perfect, down to fractions of a millimeter over vast distances. Moreover, these advancements must overcome the limitations of space missions, such as the need for miniaturization, energy efficiency, and the ability to withstand the harsh conditions of space. Despite these challenges, the potential rewards are immense. Successfully observing and analyzing the atmospheres of exoplanets could lead to the discovery of biosignatures, chemical indicators of life. Molecules such as oxygen, methane, or water vapor in specific ratios could hint at biological processes suggesting that life might exist beyond Earth. Researchers are also exploring ways to directly image these distant worlds in greater detail. Future telescopes could be equipped with advanced adaptive optics, which adjusts for the distortion caused by the Earth's atmosphere or the telescope movements, producing sharper images. Combined with the starlight blocking technologies, these improvements could allow scientists not only to detect exoplanets, but also map their surfaces and study their climates. The development of these next-generation space telescopes represents a leap forward in our quest to answer one of humanity's most profound questions. Are we alone in the universe? By redefining our ability to observe distant planets, we edge closer to finding out if life exists beyond Earth, potentially revolutionizing our understanding of our place in the cosmos. Let me know what you think in the comments box below. If you liked the video, remember to like and subscribe, and I'll be seeing you in the next video.